The internet was created as an experiment and became one of the most important technologies in human history. The concept was simple to allow two computers to share information even when physically located in different places. When multiple computers participate in this sharing, we have the internet. But the way the internet has evolved is far from ideal. Instead of people sharing data with each other in a decentralized way, we have exactly the opposite large corporations controlling most of the internet. To communicate with a friend, you use a Google email or maybe a Meta social network. Have you ever wondered why you need intermediaries or why these companies are necessary? Let's consider the following situation. Imagine there are millions of computers and you want to send or receive something from computer X. How is this connection established between your computer and computer X? You could ask your neighbor where computer X is, who will then ask their neighbors, and so on, until the message reached computer X. But this is highly inefficient. It ended up being easier to have large central points controlling the data. You communicate with the central point, and the central point communicates with computer X. It's a short path. The central points act as servers, possessing powerful computers capable of handling client requests, storing data, and distributing it. But this comes with many problems and risks such as data leaks, censorship, and loss of privacy. Is there any way to build an internet without this fragility? Yes, let me explain what Urbit is. Urbit is a decentralized internet. Just as Bitcoin enables money transfers without intermediaries, Urbit enables data and information transfers without intermediaries. On the Urbit network, users are not just clients, they are servers as well. Every user is a server and retains full control over their data. Let's understand the difference with an example. When you download an app from the Play Store or Apple Store, most of the app remains stored on centralized servers. But with Urbit, user data is stored on each user's devices. If the developer removes the app from Urbit, anyone who previously had the app can re-upload it because the essential code for its functionality is stored locally. Additionally, there is no centralized moderation charging fees. Anyone can develop and freely distribute an application. The community decides what's good and what's not. Another advantage is composability. If a social network exists on Urbit, anyone can use that code to create another social network while maintaining all previous content. So, if you join social network B created from social network A, you'll see all the connections of friends or followers you already have on social network A. Since every Urbit user has a unique identity, you don't need to create a new account for each application. Your account is always the same. You can just download an app and start using it. There's a finite and scarce number of identities on Urbit, about 4 billion. Scarcity is crucial to add value and prevent spam. Furthermore, spamming behavior in one Urbit application becomes harder because it identifies the user as a spammer across the entire Urbit network. If Bitcoin represents the scarcity of digital money, Urbit represents the scarcity of digital land. Urbit's architecture is quite interesting. The 4 billion identities I mentioned are called planets. Beyond planets, there are stars and galaxies, each with specific purpose. At the lowest level, there are also moons and comets. The stars and galaxies contribute to information routing on the network. Remember the other difficulty of finding a computer among millions? Urbit solves this by having a planet ask its stars to locate another planet. The stars then consult its galaxy, and the galaxy might consult another galaxy. This significantly speeds up the search since stars communicate with many planets and galaxies communicate with many stars. This search occurs only once. After the complete route is established, it's remembered and used directly for future communications without routing overhead. The entire network comprises 256 galaxies, 65,000 stars, and 4 billion planets. Each planet can further create around 4 billion moons and an unlimited number of comets. Moons are used for configuring IoT devices, and comets are useful for creating bots. As each Urbit identity has specific roles and limitations, Many applications might restrict comment registrations or limit their actions for security purposes. For example, a comment might be able to read the data but not change it, or something like that. This organization enhances transparency and operational efficiency. To use Urbit, the first thing someone needs to do is obtain an identity, which can be anything from a Galaxy to a Comet. The choice is yours. When creating an identity, you will want private keys for it, similar to how private keys control a Bitcoin address. Star and Planet identities are distributed among many users and traded on platforms like OpenSea, where you can filter if you want to buy a star or planet. When acquiring through OpenSea, your Urbit identity is an NFT on Ethereum. There is a bridge allowing you to use this NFT to create your Urbit identity. However, this is not the only way to obtain an Urbit identity. Moreover, there is a community proposal to create an Urbit token representing the value of a planet, allowing this token to be burned to obtain a planet. This proposal still needs community voting and, if implemented, could further facilitate identity acquisition and Urbit's popularity. Returning to Urbit's technical details, you might have noticed all these features require a dedicated operating system. Indeed, Urbit has its own OS called Arvo. Unlike Windows, Mac, or Linux, Urbit's OS was designed with principles of simplicity and modularity. To give you an idea, Windows and Linux systems have tens of millions of lines of code, making it impossible for a single person to manage or even understand everything. In contrast, Arvo's kernel has only 1,000 lines of code, making it a minimalist OS. In Urbit's technical structure, functions like networking, synchronization, or file storage are managed by separate modules called vanes. This modularity greatly simplifies maintenance and updates, helping developers interact only with necessary models for their applications, avoiding extra dependencies. Another characteristic of Urbit is its deterministic and immutable model. Each change generates events that aren't overridden. Therefore, after a reboot, Arvo recovers the exact previous state, avoiding data loss common in conventional systems. Information only accumulates, it isn't edited, similar to a blockchain, except the log is local and not replicated across all nodes. Arvo is written in a programming language called Hum, which is the same language used to create applications in Urbit. This language compiles to a low-level language called Nock, which express computation in a minimalist mathematical way. You might think of Hum being to Nock as C++ is to assembly. Hum is user-friendly and easier to handle, while Nock is closer to the machine's physics. In this video, I am to avoid overly technical details since it's an introductory view. Please comment below if you'd like another video explaining Urbit's architecture or a detailed guide on how to enter and get started with Urbit. I will also share statistics and tips about Urbit on my X account. I'm always attentive to innovations in technology and decentralization, so follow the channel if you are new here. See you soon!